electronic circuit, we will discuss today one of the important device, that is the memory device. So today we will discuss what are the memory devices and how it works and what type of memory devices we have, that we will discuss in today's lecture. So first, if we talk about the memory, is the one of the important part in the any digital system and any electronic system, and it is used to hold the data and the program required for the processing and performing the task. Another important point of the memory is that this memory affects the performance, efficiency and the speed of the digital system. And nowadays semiconductor memories are most popular, and as they provide a very high speed operation, large storage capacity and the compact size. So in keeping in view, first we discuss what is memory. In the field of the digital electronics, the memory is a device that is used to store the data and instructions in the digital system. If we talk about the computer, then all computers store the memory. We talk about the microprocessor based system, it also have a memory devices. So in the modern digital system, the memory is made up of semiconductor materials and is also known as the semiconductor memory. The memory is a device that provides the storage space in computer or any other digital system where data is to be processed and the instructions required for processing are stored. Means the memory device stores all the data and its instructions and all its processing done through this memory devices. So memory is a device that provides the storage space in any electronic system which where the data is to be processed and the instructions required for processing are stored. So the memory is divided into large number of the small parts, and each part of the memory is called the memory cell. Now each memory cell or location has a unique address assigned to it, which varies from 0 to total memory size minus 1. Like we see there, for example, if we have a computer has a 64 kilobyte memory size, then this memory unit has 64 into 1024, it will multiply by the kilobyte, it is 1024, and which is equal to 65536 memory location or the cells contained there. These are the small parts of the memory, and this is the memory location. 65536 are the memory location or the memory cell in the 64 kilobyte memory size computer. So the address of these location ranges from the 0 to 65535. So if anyone talk about that we are having the 64 kilobyte memory size, then it means we have a 65535 cells, memory cells or the memory location in the system, and these address ranges, location ranges from the 0 to 65535. Memories are made of the registers, and each register is in the memory is one storage location. So the storage location is also called the memory location. So the memory location are identified using the address. The total number of the bits a memory can store is its capacity. The storage element is called a cell, and each register is made up of a storage element in which one bit of the data is stored. Means one cell can store the one bit of the data. The data in the memory are stored and retrieved by the process that called the reading and writing respectively. Means we store the data in the form of the writing, in the form of the reading. So each bit contain the data in the form of the writing and the reading respectively. You see that is the address from the 0 to 6 we have mentioned here. In the last it is a write operation where we have a n minus 1 up to n, and right hand side we have the read operation. You see writing operation 1 0 0, these are the location of the memory, and here on the right hand side this is the location of the reading data. So in this way we just stored the data in the different locations through a particular address. So a word is a group of bits where the memory unit stored binary information. A word with a group of 8 bits is called a byte. So a memory unit consists of data line, address selection line and the control line that specify the direction of the transfer, the data how we will transfer. You see on the screen that we are having the n data lines and a memory unit 2 power k word we have n bit per word. Now k address line we have here, and read and write address we have in this memory unit. So data line provides the information to be stored in the memory. Similarly, the control input specify the direct transfer, where the k address line specify the word what we are taking. So k address line specify the word chosen. So where there is a k address line, so 2 power k memory words can be accessed through this memory unit. So what are the functional block diagram of the memory? A memory basically a group of the multiple storage cell and having a support circuit to perform the data read and write operation. So the following figures, if we have the functional block diagram of the typical memory device. You see on the screen, left hand side we have a address line. First this is a memory device. Right hand side we have a read signal, then we have a write signal, and we have a chip selection signal, where the data will be stored in this memory device. Next is the data line. We will discuss one by one. What is this address line? These lines are used to load the address of a specific memory location or the cell. Address line, these lines are used to load the address of the specific memory. Here we having the address of the memory stored in the cell, or the where is the data in a cell. Next is the data line. These lines are used to read and write the data from to the memory cell, where the data is stored. Data is stored in the memory cell. So address line used to load the address of the specific memory location or the cell. Data line are used to read and write the data from or to the memory cell. Next is the read and write signal. So this signal is used to read and write the data from end to the memory cell. It will just process from the right to the end, where the R signal is high and the data of selected cell gets loaded on the data line, where the W line goes low and data line is loaded into the selected memory cell. So read and write signal, where it is used to read and write the data from one end to the another end in the memory cell. Another is the chip select signal. This signal is used to enable or disable the memory chip, when it will work, when it will not work. So when it is enable, then it will be used, and when it is unavailable, then it will not be used. So it is the active low signal, which means when this signal goes low, the memory chip is enabled and allow the read and write operation to execute. Otherwise, memory chip will be disabled. When we enable, then it will be able or allow to read and write operation, and then it will be executed. Otherwise, the chip will be disabled. What are the functions of the memory unit? Memory unit of the computer has several functions. Number one, if we talk about the storage, so it is a stores data and the instruction. So if you take the CPU, it is also the electronic device. So memory unit stores data and instructions needed by the CPU. to perform the task efficiently. And this includes the data related to the operation to be performed and the data related to the program. Next tracks interim results. This memory unit keep tracks of the interim result of the processing. As you get the data, the processing will be done. So the interim data will be processed in the memory unit and it will keep the track of that data. Next is the saves final result. When the processing has been done, so the memory unit saves the final processing result before sending them to an output device. Last but not least, receives and transmit the input and output. As data is processed, data is saved. Now the memory unit received and transmit all the inputs and output. So the last unit is the receives and transmit input and output. So the size of the memory unit affects its speed. As if we have the size of the memory unit, as we discussed that the 64 kilobyte, then we will just calculate the location of the memory cell. Similarly, this will affect the speed, power and capacities and its capabilities. So memory size, unit size also affects the speed, power and capabilities and its capacity to store the data. Without a memory unit, the processor would have to wait longer for the data retrieval. So memory device is one of the important unit in any electronic system nowadays in the computer system that would be used for the highly to process the data. So if it is not there, then we have to wait for longer for data retrieval. Now what are the units of the memory devices? We will discuss some of the memory units, otherwise we have now it will be increased. Some of the first is the bit, that is a 1 bit, and if the size in the byte, it is 1/8. Now nibble, it is a 4 bits, 1/2, and it is very rare. We just listen about the bit and byte in the terms of the bit and byte. Now byte is equal to 8 bits, that is a 1 byte. So size in the 1 byte. After that we have a kilobyte, megabyte, gigabyte and so on, and it will be increase. But you see in the kilobyte, it is the 1024 byte. It means size in the byte is 1024. Now it will now again multiply it by the 1024. For the kilo, it will be multiplied by the 1024, and in this manner it will increase. So we define the unit. We define the unit of the magnetic devices. Now memory devices are of the two type. We define the classification of the memory device. First we see the chart of this memory devices. You see on the screen that there are the different type of the memory devices. First we have the memory devices, and it is classified into the two parts. First is the non-volatile memory, second is the volatile memory. On the basis of that, device will be developed. Non-volatile memory devices and volatile memory devices. Now non-volatile memory devices again divided into the two parts. First is the read-only memory, that is known as the ROM. And we always listen in the daily life when we just using the computer, then what is the how many ROM we have in the computer, how many RAM in the computer. So first part of the non-volatile memory is the read-only memory, that is the ROM, that is the ROM, and another part is the hybrid access memory. This is the another part. Again the read-only memory divided into the two parts. First is the write once, read many memory, that is the WORM. Write once, read many memory, that is the WORM, and second is the enable programmable read only memory. We will discuss one by one in the further lecture. So read only memory divided into two parts. Write once, second is the enable programmable read only memory. Now the hybrid access memory divided into the three parts. First is the flash memory, second is the electrically erasable, memorable, read only memory, that is EEPROM, and another is the ferroelectric memories. So these are the modern and all are just made from the semiconductor devices. Another type of volatile memory is the RAM, that is a random access memory, and this random access memory again divided into two parts. First is the dynamic random access memory, that is the DRAM, and second is the static random access memory, that is SRAM. So we will discuss one by one in all the memory. So memory divided into the primary memory and secondary memory. Now we will discuss that. First we have seen the chart of the memory devices divided into two parts. First is the non-volatile, second is the volatile. Non-volatile again divided into the read-only memory and the hybrid access memory. Volatile is the random access memory. After that they are again subclassified. Now we see that the memory primary classified into the two types. First is the internal memory, second is the external memory. The internal memory is also known as the primary memory and is connected to the hardware architecture of the digital system, and it is typically installed in the system's motherboard in the form of the ICs. All the memories in the form of the IC. So classification of the memory in the two type. First is the internal memory, that is the primary memory, and the primary memory is the hardware architecture of the digital system. And second, and if we take the example of that, are the RAM and ROM. These are the primary memory, and these are the internal memory also. External memory is the secondary memory. This memory is not directly connected to the hardware architecture of the system. Instead it is connected through the cables as a peripheral devices. And external memory is primarily used to provide the additional storage space to store the data. Like you have seen the CD, it is the external memory devices, DVD, HDD, SSD, USD drivers, and hard disk. These are the external hard disk. These are the external memory devices. These are not directly in the architecture system, hardware architecture system, but these are the secondary device. External memory storage is also external hard drive are the secondary type of memory. So it is the external memory. So we have the two types of memory, internal and external. Internal inside in the motherboard, and external which is connected outside. Now memory hierarchy we will define as the arrangement of the different type of memory used in the digital system, and depending on its characteristics, primarily speed and its capacity. So memory hierarchy helps us to select an appropriate memory to use in a system at a specific level. So a typical memory hierarchy of the memory for the different memory devices are here. You see that here is the register, second is the cache memory, or third is the main memory, and fourth is the secondary memory. So these are the hierarchy of the memory storage devices installed in the system: register, cache memory, main memory, and the secondary memory. Some of the key characteristics of this memory hierarchy, and when we go from top to bottom. Capacity, how we select? Number one, capacity in terms of the storage increases. Means we have that type of memory up so that we can increase the capacity of the storage system. Sometimes we have a data overloaded, so we have to use the we have to increase the storage capacity. So we will put hierarchy, we will keep the memory hierarchy in such a manner so that we can increase the storage capacity. So first is the capacity in terms of the storage increases. Second is the cost per bit of the storage decreases. Third is the frequency of excess of the memory by CPU decreases. Fourth is the excess time by the CPU increases. So, keeping in mind, just we put the hierarchy of the memory system. So, next is what are the important terms related to the memory operation. There are the many terms, we are having many important terms and definitions which are related to read and write the operation of the memory. Number one is the write cycle time. So, this write cycle time is defined as the minimum amount of the time for which a valid cell address is available for the data writing operation in the cell. Means we are writing a data in a cell, so we require the minimum amount of time. So, this write cycle time, just typically it is a just write cycle time, just having the minimum amount of the time for which a valid cell address is available for the data writing operation in the cell, and typically it is order of the 200 nanoseconds, means 200 nanoseconds we can write a data in a cell. Second is the write pulse time. The minimum duration of the write pulse is terms as write pulse time, and it is of the 120 nanosecond. Third is the write release time, the minimum time for which the memory address is valid before the write pulse is known as the write release time. Another is the data setup time, the minimum amount of the time for which the data remains valid before the write pulse add is known as the write setup time, and its time is 120 nanosecond. We just write the data and it will be set up for the processing. So, it is in the order of the 120 nanosecond. Next is the data hold time. This is the minimum amount of time for which the data remains valid after the write pulse ends, and that is the data hold time. Means when it is pulse is not, write pulse is not there, still the data will be in the system. So, it is next is the read cycle time. Again it is the same, when the minimum amount of time for which a valid memory address remains available for reading the data from the memory is known as the read cycle time, and it is order of the 200 nanosecond. Next is the access time. The amount of time required to access the data from a memory cell is referred to as a access time of the memory, and it is order of the 200 nanosecond. Now, next is the read to output active time. Read to output activate time, and this minimum time that required for enabling the output buffer after starting of the read pulse is called the read to output active time, and typically it is order of the 20 nanosecond. This is a very short pulse. So, next is the read to output valid time, and this is the minimum delay time between the beginning of the read pulse and the availability of the valid data at the data output line, that is the read to output valid time. And these are the basic terminology that we will use in the memory devices. We will further discuss the characteristics of the memory devices, classification of the memory devices in the next lecture. Thank you very much.